Good morning and welcome. Our hearing will now come to order. I want to thank our witnesses and my colleagues and panel, and as well as staff and the other people in the audience. Our hearing today is on developing a national climate service. We'll discuss the need for climate services, the type of services being delivered, and options for meeting the increased demand for climate information. As we all know, climate affects all of us every day in communities across the country. As our ability to understand and recognize climate cycles and patterns has grown, so has the demand for more climate information. This committee passed legislation in the 107th Congress, authored by Representative Hall, to expand climate services by authorizing the National Integrated Drought Information Service, or NIDIS. Droughts have taken an increasing toll on individuals, natural resources, and businesses in recent years, and these impacts have not been confined to the western U.S. The southeastern U.S. has experienced persistent drought conditions that still have not been completely alleviated in all areas. The severe shortage of water drove power plants to temporarily shut down, created financial hardships for recreational businesses, and loss in crop yields for farmers. Without some ability to predict the intensity and duration of these climatic events, state and local governments cannot develop plans to respond to them. That is why we need climate services. There are many examples where climate predictions have been useful in making important decisions. In our part of the country, the Pacific Northwest, data on snowpack provides critical information to decision makers and water managers about the likely availability of water through the spring and summer months. The long-term data records that we have acquired through years of monitoring the weather indicate the climate is changing. Whether you believe this is due to greenhouse gases or to natural long-term shifts in climates, we still need to understand the phenomenon and adapt to it. Therefore, it is in our best interest to structure a service that will utilize expertise to develop information that will not only support us nationally, but at the regional and local scale where adaptation and response plans can best be implemented. Today, we'll hear from witnesses who deliver climate services and from those who use them. I look forward to hearing the recommendations for refining and expanding climate service to better address the needs of communities, businesses, and individuals for climate information that will reduce their vulnerability to weather and climatic events. I also look forward to hearing from the Administrator of NOAA, Dr. Lubchenco, about the administration's plans for improving the delivery of climate services to the country. We may not be able to control the weather and climate, but we can prepare for it and adapt to it if we know what we're facing. With that, I look forward to the testimony we'll receive today. I want to thank our witnesses and now recognize the distinguished ranking member, Mr. Inglis, for his opening remarks.
Thank you, Mr. Chairman. Thank you for holding this hearing. While Congress continues to debate the right way to reduce our greenhouse gas emissions and limit future anthropogenic changes to our climate, farmers, water managers, land use planners, and other decision makers are trying to plan for the impacts of climate change that we can expect over the next few decades. We have a lot of work to do to provide them with the information they need. NOAA has done a good job of identifying existing capabilities and launching the process of constructing a national climate service at the federal level. In addition, the Science Advisory Board's report, Options for Developing a National Climate Service, highlight the challenge of coordinating the unique roles of several federal agencies. I'm interested in learning more about how we can marry federal services with research universities and state climatology offices to keep the focus on local users. Existing climate information services aim to provide tools for seasonal and yearly planning. In South Carolina, we use this information to decide what crops to plant, how to manage our water supply, and whether we can expect forest fires like the ones that raged on our coast last month. The testimony we're going to hear today highlights the critical importance of this information. The challenge is also to expand these services and provide accurate information to a wide variety of users for both short and long-term decision making. We also need to have a serious discussion about resources at NOAA. Existing observation and monitoring networks need to be updated, computing capabilities are insufficient for local modeling, and information delivery needs to be improved to get the right information to the right people. These efforts won't be inexpensive, and we need to identify those needs now. Thank you again, Mr. Chairman, for holding this hearing, and thank you to the witnesses for appearing here. I look forward to learning about our progress toward a national climate service and what obstacles remain.
Thank you, Mr. Inglis. It's really a pleasure now to be able to introduce Dr. Jane Lubchenco at her first visit to this committee. I'm sure it will be the first of many to come, and I thank you very much for your time. New administrators are always busy, but especially at the start of a new administration, and we very much respect your time. But I do want to take the time for my colleagues and for members of the audience and others to be aware of just how impressive the resume of our new director of NOAA is. Dr. Jane Lubchenco, a marine ecologist and environmental scientist, is the 9th administrator of NOAA. Her scientific expertise includes oceans, climate change, and interactions between the environment and human well-being. Raised in Denver, she received a BA in biology from Colorado College, an MS in zoology from the University of Washington, and a PhD in ecology from Harvard University. While teaching at Harvard from 1975 to 77 and Oregon State from 77 to 2009, she was actively engaged in discovery, synthesis, communication, and application of scientific knowledge. Dr. Lubchenco has studied marine ecosystems around the world and championed the importance of science and its relevance to policymaking and human well-being. A former president of the American Association for Advancement of Science, the International Council for Science, and the Ecological Society of America, she served 10 years on the National Science Board, which this committee knows is basically the board of directors for NSF. From 1999 to 2009, she led a large 4-university interdisciplinary team of scientists investigating the large marine ecosystems along the coast of Washington, Oregon, and California. She has a special interest in Arctic ecosystems. Her scientific contributions include 8 publications which are considered science citation classics. She is one of the most highly cited ecologists in the world. She's an elected member of the National Academies of Sciences, the American Academy of Arts and Sciences, the American Philosophical Society, and the Royal Society. She's received numerous awards, including a MacArthur Genius Fellowship. Why don't we ever get don't answer that question. 9 honorary degrees, the 2002 Heinz Award in Environment, the 2005 AAAS Award for Public Understanding of Science and Technology, the 2008 Zayed International Prize for the Environment. She has also served on the Pew Oceans Commission and the Joint Oceans Commission Initiative and the Aspen Institute Arctic Commission. Clearly someone who is totally unqualified for the position, to a remarkable resume. The latter was a joke. This is an extraordinarily well-qualified, impressive individual. We're grateful for your time and your expertise, and in respect for that time and the various demands, I've asked that you be solo up today so we can move quickly through what you have to say and our questions, and then we'll recognize other panels as follows. So with that, as witnesses should know, we'll have 5 minutes for your spoken testimony. We've received your written testimony, and then following your testimony, Dr. Lubchenco will alternate between the two sides. Thank you, and please begin.
There we go. Is that on? Thank you, Chairman Baird, Ranking Member Inglis. It's indeed a great pleasure for me to be here, and I too look forward to strong, productive, ongoing interactions with the subcommittee and the full committee. So thank you for your warm welcome. I'm here today to discuss some of the benefits of the National Climate Service and what it could provide to the nation as we work to adapt to a changing climate. I will also share with you our vision for how NOAA will work with other government agencies, the Executive Office of the President, and a diversity of public and private sector partners to help shape a national climate service, one that builds on existing capabilities but also leverages the capacities of a range of federal agencies and other partners to develop new and vitally useful information, services, and delivery mechanisms. The nation has already benefited from a sustained federal and extramural partnership and collaborations aimed at documenting and understanding climate change. Federal interagency collaborations, such as the climate change research efforts of the U.S. Climate Change Science Program and the U.S. Global Change Research Program, have produced state-of-the-art guidance through 21 synthesis and assessment products and the forthcoming State of Knowledge report on global climate change impacts in the U.S. We are indeed very proud of these achievements. Reports like these do an outstanding job of synthesizing existing scientific information. They do not, however, even begin to deliver all of the guidance now being sought by decision makers from private and public sectors from local to international levels. To fill this void, a number of efforts have arisen to provide some climate services, and you will hear about many of those today. Each of these is important, but collectively they are insufficient to meet the growing demand. More work and better integrated mechanisms are needed to provide usable, credible, salient information on an ongoing basis. In particular, more work is needed to understand users' needs and to deliver climate-relevant information at the appropriate scale in a fashion that is both true to the scientific knowledge but also sensitive to users' diverse styles and needs. Just as the nation's climate research efforts have required sustained federal agency partnerships and strong engagement of academic and other partners, a new effort to provide climate services will also require sustained federal agency partnerships and collaboration with climate service providers and end users. It is time to learn from and build on existing efforts, but to take them to a new level of usability and usefulness. There is unequivocal evidence that the Earth is warming. This warming can be seen in increases in global average surface air and ocean temperatures, widespread melting of snow and ice, rising sea levels, and changes in many other climate-related variables and impacts. The impacts of our changing climate are regionally diverse and relevant across numerous sectors, including water, transportation, forestry, coasts, fisheries, and human health. These impacts are expected to grow in response to projected future climate change. Weather and climate have profound impacts on our nation's economic and social well-being. Drought alone is estimated to result in average annual losses of between $6 and $8 billion to all sectors of the economy, including transportation, agriculture, and energy. The nation's systems and infrastructure for water, energy, transportation, agriculture, and other sectors have been designed and built based on what we know about current local environmental conditions or our understanding of the recent past. The assumption has been that the past will be a good indicator of the future. In similar fashion, our approaches to the management and conservation of ecosystems and species have been based on current and recent climate conditions. But now, the background patterns of temperature, rainfall, snowfall, and more are changing. For example, in the Northeast U.S., the number of heaviest precipitation days, defined as the heaviest 1% of all precipitation events, has increased by a startling 58% since 1958. Throughout the country, rapid climate change is presenting new challenges for managing water, building in coastal zones, growing food, providing clean energy, and helping to keep Americans healthy. As a consequence, decision makers at all levels of government are seeking information to help them prepare their communities for the impacts. In similar fashion, the private sector is hungry for similar information to guide their planning. It is increasingly clear that the nation needs an objective, authoritative, and consistent source of consolidated, reliable, and timely climate information at the appropriate scale to guide decision-making. This concept of the National Climate Service as a single point of accountability has been studied by the National Academy of Sciences, external advisory groups, and others. Each of these reports has raised serious issues and has caused our thinking about a climate service to evolve. The overarching goal of a National Climate Service would be to provide the essential information about climate change that is needed for effective decision-making. A National Climate Service would enable public and private sector decision-makers, resource managers, and the public to better anticipate, plan, and respond to impacts of changing climate conditions. A National Climate Service will build on many agencies and other organizations' strengths and expertise and rely upon strong partnerships across all levels of government, academia, and the private sector. Because NOAA already provides many climate services and data, because it has recognized scientific leaders with climate expertise, and because it has considerable experience in providing a range of other services, NOAA is well positioned and ready to work with a range of partners to help lead the development of a National Climate Service. The scientific basis for evaluation of climate change and its impacts must continue to come from existing collaborative efforts with the relevant leading agencies including NOAA, DOE, NASA, EPA, DOI, and NSF. These agencies will provide much of the data, information, and knowledge that will support a national climate service. The pace and nature of changes in Earth's climate reinforce the need for delivering targeted climate services. Much work lies ahead of us. We will need to draw from the experience of all of our partners to support the development of science-based and user-driven climate services. NOAA will contribute to this effort by building on its existing capacities and partnerships and networks to deliver an evolving suite of climate information and services in collaboration with our partners. We are prepared to provide the leadership in partnership with other federal agencies to the design and development of a national climate service through an interactive dialogue that engages the breadth of climate service providers and interests, including providers, researchers, and users. I look forward to working with the committee, the White House Office of Science and Technology Policy, other federal agencies, and our partners to further evaluate and design the merits of this effort. Thank you very much for the opportunity to testify, and I'm happy to answer any questions.
Thank you very much, Doctor. I'll recognize myself for 5 minutes. You know, when you talk about the implications of this, Mr. Inglis talked about fires. We look in our area in terms of El Nino events, whether there or not will happen has profound implications for our agricultural industry, our power supply, a host of other fishing, for example, in the Northwest, as you know better than I. So this is really something we recognize on this committee the importance of. The question then is really, what are the best way, how do we best go about structuring this, given that there are various aspects, as you mentioned, various aspects of what the data can be used for. We'll hear from a panel in a minute about that, but also various entities within government that also provide some of the pieces. What are your thoughts about the best way to put the pieces together? Do we have a coordinating body? Do we create a new entity? Do we draw upon the various agencies separately, or do we integrate them? What are your thoughts? And we'll hear, there may be other thoughts later on we'll hear, but what are your ideas about this?
Mr. Chairman, I believe that this topic has actually been addressed by some of the different studies that have looked at this concept of National Climate Service. And there are some continuing themes that loop through each of those different reports. The need for an integrated national effort, number one, an effort that draws on the wealth of existing research information and is tied to the ongoing discovery of new information. Three, an effort that is connected to and cognizant of users' needs. And three, that draws, that draws on the wealth of experiences that currently exist through existing federal agencies, for example, within NOAA, the experiences we've had with the National Weather Service, but the regional climate centers, the regional integrated assessment and service organizations that are providing a wealth of existing climate services. So I think to sum that up, there are a lot of existing pieces in play. I believe that a single effort is needed to look broadly across those capacities and lessons learned and to integrate them at the federal level. I would envision an interagency process led by the Office of Science and Technology Policy as the appropriate entity to really take stock of and lead that designing effort. We now, I think we have gotten to the point where we are in agreement that something is needed, something that does not now exist. And the question is how to design that. Typically in an interagency process, there is a lead federal agency. NOAA is willing to play that lead. We would not insist on that. It just seems logical because of the wealth of our capacities, capabilities, and experiences. But I believe this really is an interagency process, but one that does not ignore the regions and the local experiences and capacities, because it really is delivery of services at the local and regional level that should be the focus.
I share that belief that NOAA is the best suited and qualified and has the longest history of dealing with this, so I would certainly support that. Let's talk a little bit about the applications now. how would you envision, obviously for agriculture, this is critically important. When you look at, and downstream for those of us who eat the products of agriculture, it's important. When we look at predictions of what might happen, for example, to the regional ability to grow different crops or needs for irrigation or chemicals or other factors, how do you envision getting the information out effectively to the various regions of the country, which will have different needs based on crops and climate in those regions?
Mr. Chairman, our current ability to make reasonable forecasts about climate scale information is really best at the scale of the entire continent and best at the scale of a century. Neither of those time or space scales is what we need. Our modeling capacity is getting better and better, and with the recent new supercomputers, we have reason to believe we will be able to deliver regional scale information, hopefully on the 20, 30, 50-year time frame. So our capacity to provide the kind of information that users are asking for and needing is getting better and better, which is why it's so timely to be designing the mechanism for sharing that information with users that are asking for it. So relative to what trees to plant, what crops to plant, how to think about water management, how to think about fire management, how to think about building coastal cities, all of those will require information that is at that 20-plus time horizon and more at a regional scale. So that's where we need to be heading.
So we have a combination of a challenge of the research necessary to refine the precision of our instrument, of our predictions, but also then a process of making those predictions relevant and valuable to the consumers in the field.
Yes, Mr. Chairman, although I think it's probably more appropriate to be talking about forecasts as opposed to predictions. Predictions implies more certainty than will probably be appropriate, but forecasts, much like we do for the weather forecast with some uncertainty described, is probably what we're looking at.
Thank you. Recognize Mr. Inglis for 5 minutes.
Thank you, Mr. Chairman. Dr. Lubchenco, we very much appreciate your work at NOAA. And, you know, I was interested in your observation that NOAA is well positioned to collaborate, and I can definitely speak to that, having been with Dr. Baird in Australia and seen employees of NOAA there. It's very impressive that NOAA is that extramural, I think you called it, that we are. I'm also in Foreign Affairs as well as the Science Committee, and is realizing the opportunity there to generate and keep, in the case of Australia, goodwill by having our employees present there working on something that's very important to them, the Great Barrier Reef, but also is important to us in gathering science and information. This really is it substantiates what you were saying about NOAA being well positioned to lead this collaboration. So tell me, for folks that are concerned about creating new things in the federal government, the goal seems to me is to create stronger, smarter, simpler, more flexible kind of government agencies. How would this fit with that criteria, or would it just be growing larger? The concern that a lot of people have is we grow the federal government larger.
Thank you for that question. I think that it is likely the case that we can make better use of many of our current capacities, make them more efficient, make them more synergistic, connect international, federal, regional, and local efforts in a more efficient fashion. That said, what will be required and what is already being asked by many users of us will require significantly greater investment than currently now exists. So I think we can do some combination of synergies and finding efficiencies, but that alone will not be able to deliver the range of products and services that we believe would best serve the nation.
So, in other words, your hope is, I suppose, to actually get more bang for the buck in terms of the expenditures, more synergistic effects. Of course, that's what we're looking for in the federal government, seems to me, as we think about ways to make it stronger, simpler, more effective, more efficient. So I hope that's that is what we can achieve here. For some
Congressman Inglis, could I clarify? I do think that that is possible, but I also think that we are talking about something new as well, that there are there will be new efforts required to, in addition to the synergies and the efficiencies, right, to be delivering the services that we think are going to be needed.
Right, and of course our challenge is, as members of Congress, as we encounter these new challenges, we need to go figure out what it is that we've already licked and get rid of some of those things. You know, there are places in the federal government where agencies keep on going forever long after the problem is licked. So hopefully we can do that together. We can add to capabilities here, but eliminate things elsewhere, perhaps in NOAA, but also, certainly across the federal government and other places. So I have just a brief little time left, but it's a good way to ask the question, I suppose, with a time limit. Let's say you got on the elevator out here and somebody told you just nonsense that there are anthropogenic causes of climate change. What was your elevator answer? You got 3 floors, you have 49 seconds to get down to the bottom. What would you say? I'm just curious.
Regardless of what you think the causes of climate change are, I think the evidence is unassailable that there is change underway. And most people are experiencing that in their daily lives. The temperatures are increasing. We're seeing more extreme precipitation events, more floods, more droughts. We're seeing, as a consequence, more fires, more insect outbreaks. Sea level is rising, and the oceans are becoming more acidic. And all of those changes are well documented. Now the challenge relative to the topic of today's hearing is how do we deal with those changes in a way that is most useful.
Great. Thank you. The elevator just got to the first floor.
Thank you, Mr. Inglis. Recognize Ms. Woolsey for 5 minutes.
Thank you very much. Thank you, Doctor, for being here. We're so pleased to have a real scientist leading your organization, so congratulations.
Thank you, Congresswoman.
It gives all of us a lot of confidence that we're going to go in the right direction. In your testimony, you talk about global climate change and how National Climate Service can be used in mitigation and adaptation to the problem that we're creating. So this leads me right up to where do you see the role of the National Climate Service in monitoring greenhouse gases?
Congresswoman, it really is important that as we think about different types of mitigation and as we work toward the best way to reduce greenhouse gas emissions, we will need to monitor the types of or the amounts of greenhouse gases that are being emitted and that are in the atmosphere. And we currently do some of that. We need to be doing more of that, and we need to have mechanisms to be reporting that on an ongoing basis. So I think there is absolutely a need to have that capacity.
So would that be when you talk about Congressman Inglis asked about, growing our government, that new doesn't mean that we replace existing. So would this be some of the new responsibility?
We already do some monitoring of greenhouse gas emissions. We need to be doing that on an ongoing basis and probably at greater scale for verification purposes. So that need will continue and will grow, along with the need to provide information that will focus more on the adaptation end of the climate challenges.
So are there any other examples you'd like to give us of what new programs we will need and while we continue with our existing important NOAA programs?
Well, I think some of the other benefits of having something like a climate service would be enabling those in the private sector who are thinking about new types of renewable energy sources, information that would enable them to do a better job of having successful businesses. Say, for example, that you are interested in building a wind farm. You would like to know not where the winds have been good for the last 100 years, but where they're likely to be good for the next 100 years. And so that information would be extremely useful to you in helping to design where to place, where to site, decide whether this is a good investment or not. So there are many kinds of services that a National Climate Service could provide that would help with creation of new jobs, new industries, and provision of clean energy.
So do you see a need for the oceans being considered in relationship to climate? Where is that going to come into play?
Oceans and coastal areas are being strongly affected by the increased greenhouse gases in the atmosphere. This committee has been, and the chairman in particular, have been strong champions of focusing on the changing chemistry of the oceans. As oceans are absorbing the carbon dioxide, they become more acidic, and that in turn is affecting our ecosystems, especially along the West Coast, but also elsewhere. In addition to that, ocean ecosystems are responding as a result of changes in temperature, changes in ocean currents, changes in coastal winds, and then, of course, sea level rise. And all of those consequences of climate change to ocean ecosystems are affecting the way people interact with those ocean ecosystems, whether they're on the land side or the ocean side. And as we deal with this range of changes that's underway, information to help guide decisions about growth in coastal areas, planning of where to move infrastructure, planning of where to move communities, where to build airports, where to build wind farms, wave energy facilities. All of those will be vastly enhanced by having more, by having information that we envision being able to be provided by a National Climate Service.
Good. Thank you very much, Mr.
Thank you, Ms. Woolsey. Dr. Ehlers.
Thank you, Mr. Chairman. I have no questions, but I did just want to say I'm very pleased that Dr. Lubchenco has received this appointment, and I look forward to a lot of good work happening in NOAA in the future.
Thank you, Congressman, and thank you for all of your efforts over the years as a strong champion of science.
Thank you.
There has been no stronger champion over the years than Dr. Ehlers, and you will appreciate his expertise in many realms. And Dr. Ehlers, thank you. Mr. Rohrabacher.
Thank you very much, Mr. Chairman. And I've been a longtime fan of NOAA, and I wish you success and look forward to working with you.
Dr. Lubchenco, be advised that Mr. Rohrabacher is an avid surfer, and so he brings us the perspective of someone who spends a lot of time in the water.
As well as scuba diver, let me note that, but not as avid a scuba diver as my chairman. The climate change, you're referring to climate change. Were you at any point in your career someone who used the words global warming instead of climate change?
Yes, Congressman, I think most of us have used both of those terms.
Why is it that you stopped using the word global warming and have now moved to climate change?
The words global warming to me imply something that is gradual and something that is only about temperature. And the sum total of the changes that are underway are much more than just gradual and just temperature.
Okay, so, but the temperature change itself, correct me if I'm wrong, for the last 8 years there has not been higher temperatures. Could that have something to do with your change of wording from global warming, to climate change?
No, sir, I don't believe that the change of wording, at least in the way that I understand the words, is anything other than an honest attempt to communicate better with the public about the range of changes that are underway.
Well, I'm sure you are always, I am in no way implying you ever were people who I disagree with have ever been dishonest with the public. Let me just put that on the record. People can have honest disagreements, but also people can be wrong. And my suggestion is that there's so many people who are using the word global warming and now don't use it because it hasn't been getting warmer. I think it's, and I'm not saying this about you, but for many other people, I think it's that they were wrong and refused to admit it. Let me ask you, so is that correct that there has not been warming on the planet generally in the last 8 years?
Congressman, I think may I use an analogy that is on the beach, if you will. If you are standing on a shore that you've never been at before, and you're trying to decide if the tide is going in or coming out, and you watch 8 waves come in, you can't tell whether the tide is ebbing or flowing. You need to look at it over a longer period of time. The same is true with climate records. Looking at an 8-year record is insufficient to tell you if there's any meaningful change through time. You need a longer period of time to be examining whether there really is a change, whether it's going one way or another.
I was assuming that the Weather Service and the scientists that were using the words global warming had actually been studying the trends over long periods of time. Tell me, is the climate on this planet, someone who is an expert in this area, would you say the climate on the planet over the millions of years of our planet's history has been a stable climate or someone that has been volatile?
Over millions of years, the climate has gone through many different cycles. We have good evidence going back some 650,000 years from ice core data, for example, that give us better insight into that fairly long period of time. And during that interval, we know that what is happening now is outside of the normal ranges of the climate cycle.
But there's been major changes in the climate over that time period. About ice cores, does the ice core prove, and I've heard several scientists that we've been put on record here, major heads of major university science laboratories, et cetera, that have said that the idea that CO2 introduction has caused the climate to change was the wrong analysis 10 years ago, and they've studied it, and they now believe that it's warming that causes the CO2 to go up and not the other way around. Do you disagree with those scientists?
I disagree with that, and I think there has been resolution of that particular issue. I think it's now commonly accepted that increases in carbon dioxide are in fact causing both a general warming trend and increasing variability of the climate, and there's good evidence that that is happening.
And has the CO2 gone up in the last 8 years, and we have not seen, instead we have a cooling now, yet the CO2 continues to go up?
Congressman, this is the same phenomenon that I was describing earlier. 8 years is not enough to detect a trend in a system that has some natural fluctuation, and we're seeing over the last century significant warming through that time and very significant increases in carbon dioxide. I think there's considerable unanimity within the scientific community on those points.
I would just suggest that I've already put in the record many scientists, prominent scientists, who don't agree with that. And my time is up. Thank you very much, Mr. Chairman, and thank you to the witness.
Thank the chair, Mr. Rohrabacher. I don't plan to have a whole second round, but What are we seeing in the area of ocean acidification over the time period? This is basic chemistry. Is there anyone who would suggest that more CO2 in the air is going to lead to less acidification of the ocean and less adverse effects? You're an expert in that particular area. Could you enlighten us a little bit about that?
Mr. Chairman, this is an area where there really is no controversy at all. It's very straightforward chemistry. As you increase the amount of carbon dioxide in the atmosphere, the ocean absorbs it, and that makes ocean water more acidic, is the very simple, straightforward thing. We know that over the last 100 years or so, the amount of acidity in the ocean has increased by about 30%. And that is having a very significant impact on everything from coral reefs to the microscopic plants in the ocean, the phytoplankton, on anything that has a shell or a skeleton, from mussels to clams to sea stars, sea urchins, oysters, and all of those changes that are underway are likely to continue for some time because of the carbon dioxide that's in the atmosphere now.
Even if we were to stop additional CO2, we would still have continued acidification impacts.
We would indeed.
Unless any of my colleagues have urgent questions, I think we will thank the Director for her service. Look forward to many future conversations and working closely with you and your agency on developing a national climate service and legislation to support that. And with that, we'll take a brief break. Dr. Lubchenco, you're excused, and thank you very much for joining us again. Hope to see you soon.
Thank you so
much.
much.
A very brief break as we seat the next panel and our staff puts the proper name tags in the proper place. Thank you again, Dr. Lubchenco, and thank my colleagues. Our panel is now seated. We want to thank the panelists. I'll also acknowledge we've been joined by Edinburgh East Johnson as well, the gentlelady from Texas. And we will now introduce our second panel. Thank you for your patience, gentlemen, and thank you for your background and contributions today. Dr. Arthur DeGaetano is the director of the Northeast Regional Climate Center. Dr. Eric Barron is the director of the National Center for Atmospheric Research. Dr. Philip Mote is the director of the Oregon Climate Change Research Institute and Oregon Climate Services at Oregon State University. And Mr. Richard Hirn is the general counsel and legislative director for the National Weather Service Employees Organization. Thank you all for being here very much. We look forward to your comments. As mentioned earlier, each witness will have about 5 minutes to speak, and you'll watch the lights and they'll turn yellow when you're about 1 minute, and we try to keep it as close as we can to 5, and then we'll follow with a series of questions by panel. And with that, we begin by recognizing Dr. DeGaetano. Thank you.
Thank you, Chairman Byrd. I'm a professor at Cornell University and director of the Northeast Regional Climate Center. The NRCC is one of 6 regional climate centers that have been supported by Congress for nearly 2 decades. It is administered by NOAA. We provide timely, efficient, and reliable climate services to a wide variety of sensitive sectors within our regions. I hope this experience will serve as a model for climate services in the years to come. In the next few minutes, I will elucidate several key characteristics of climate services based on the 25-year history of the RCC program. As I expand on these characteristics, please try to see the ties between them, because just like effective climate services cannot be done by any one organization, the characteristics of climate services in general are also interwoven. The first characteristic is partnership and integration. Partnerships are critical. The climate centers have seen this in our interactions with the National Climatic Data Center and with partners represented by many of my fellow witnesses. Web-based tools developed by the RCCs facilitate climate services by local National Weather Service offices, state climatologists, and Natural Resource Conservation Service offices in every U.S. county. They integrate data from across the state, local, and other federal networks that are used by these partners, another key area of integration. Partnership should also extend to our stakeholders. Trust-based, active, two-way dialogues between climate scientists and users of climate information is critical for effective climate services. Examples based on this feature can be relatively simple, but solve a substantial problem for the user, like the investment banking industry's need for degree days to be tabulated from Friday to Thursday to match industry practices, or more complex, such as ongoing applied research to develop climate-dependent tools for monitoring and controlling the spread of vectors of West Nile virus. Such data-driven climate decision models will become more and more entrenched in climate services in the coming years. It is not enough to just provide climate data. Users require climate products, and these analyses must be capable with interacting with other models. A robust computer infrastructure that operationalizes research results and dynamically links data to decision tools is a third climate service component. We have seen this in our interactions with the RESAs. The RCC computer infrastructure interfaces with hydrological models developed by the climate impact groups at the University of Washington in Chairman Baird's home state, providing real-time data for water management decisions. Responsiveness to local and regional issues is a fourth component. Responsiveness not only includes being there day in and day out to provide the types of operational products described previously, but it also includes the ability to react when unanticipated climate anomalies develop, be they hurricanes, droughts, or other crises indirectly related to climate. Just the other day, my center provided data to help track the spread of the hemlock woolly adelphid, an invasive pest. Responsiveness also includes being in tune with important political, social, and environmental considerations within a region. A climate center example from the Northeast involves the influence of climate on nitrogen runoff into the upper Susquehanna and Chesapeake Bay. The above example also highlights interdisciplinarity. Having climate service partners affiliated with universities offers ties to disciplines outside the atmospheric sciences, provides a link between basic and applied research, and capitalizes on established affiliations with Cooperative Extension, the land-grant college system, and NOAA Sea Grant. I once heard a farmer say that she deals with change every day. Changes in technology, changes in economics, changes in environmental regulations. Climate is only one of the many changes facing agriculture and other industries. This highlights the final element of a national climate service, that it be prepared to deal with adaptation to climate change. I leave this critical component for last to make the point that traditional approaches to solve past climate problems, like I have discussed, trust-based relationships with stakeholders, partnership, interactive decision tools, modeled link with data, collaborations between climate service providers and researchers from other disciplines provide the foundation for responding to concerns about future climate variations and change. Let me conclude by saying that the United States needs a comprehensive national climate service that has the ability to address the broad spectrum of climate needs facing the nation. The existing core set of organizations and capabilities provides a useful and functional framework. To meet newer challenges, this incomplete infrastructure requires consistent and reliable support, augmentation of capabilities, and much better integration across a wide variety of boundaries. NOAA capabilities and affiliated programs such as the regional climate centers will be integral and necessary components, but alone are not sufficient. Thank you for your attention.
Chairman Baird, Ranking Member Inglis, and members of the subcommittee, thank you for inviting me to testify on the important topic of creating a national climate service. My name is Eric Barron, and I'm the director of the National Center for Atmospheric Research. The climate debate has changed dramatically over the last decade. We now know that we are going to be forced to make a number of decisions that are climate related, and some mix of adaptation and mitigation is going to be inevitable. Unfortunately, our nation is not ready for those decisions. It lacks the capability to provide a diverse range of climate information that could benefit society. The simple fact of the matter is there is no single source of authoritative, credible, and useful information that will allow society to span the connections between climate and human health, water, energy, changes in severe weather, agriculture, and environmental stewardship. It's interesting, every time I talk to a natural resource manager, I discover that many of them just don't know where to go to get the information that they need. And many of them are particularly concerned that they need information that is authoritative, the very best information available if they're going to make decisions that can withstand the tests of our society or even of litigation within our society. You know, consider the fact that we have dozens of climate models out there. Should a manager from Washington State or from South Carolina, California, Texas, or New York turn around and just pick whichever climate model they might want to use for a particular problem? Or would we rather have a single source where you can go see the full range of predictions and see with those full range of predictions the information about uncertainties and their ranges and other expert opinion? In other cases, we know that if we can put users, information, and new research together, we can actually solve problems. We can tailor the information to the needs of a user to remarkable benefit. Recently, I chaired the Climate Services Coordinating Committee, a body within the Climate Working Group of NOAA's Science Advisory Board. The committee prepared a report that was entitled Options for Developing a National Climate Service. I would like to bring the conclusions of this report to your attention. First, NOAA must play a key role in any climate service. This agency already contains many of the fundamental components of a climate service, and it has a considerable history of providing authoritative services to the nation. However, in the panel's opinion, weather and climate within NOAA have to be better integrated, and research operations and users have to be better joined if their role is to be successful. Second, in addition to NOAA, there are several federal agencies that are positioned to contribute expertise, information, and resources to support a national climate service. Each federal agency needs to define collaboratively its role and its level of commitment to this service, and it can't be optional. It needs to be persistent and consistent. Third, to make this work, the overall authority and guidance must be at the highest possible level within the federal system, preferably within the White House. There are simply too many pieces out there in too many federal agencies to have this work well without clear and potent leadership. Fourth, a national climate service requires a defined, independent budget that's large enough to influence the direction of the Climate Service and ensure that we achieve its mission. Some of our most successful regional climate services are chronically underfunded, and not all parts of this nation are even represented. The service needs a budget that is appropriate to match societal need. Fifth, the service needs to be able to connect with and actively engage a broad range of users. We need a nimble and flexible structure that empowers users, that can put industry at the table, that can promote interaction between users and the research community. Frankly, this is something that the federal government doesn't do well. Our view is that we need a separate consortium or nonprofit that is directly funded through a lead agency and is designed specifically to promote this interface. We need an entity that has a single focus, no competing agenda, in order to connect credible climate information to those who need it, whether it's a city, a state, a climate services corporation, or a research manager. I believe that a national climate service that is structured well and implemented effectively will dramatically increase our ability to respond to these challenges. The potential to serve our nation, I think, is enormous if we do this well. Thank you for this opportunity, and I would be pleased to answer any questions when the time comes.
Thank you, Chairman Baird and Ranking Member Inglis and members of the committee. I am still with the Climate Impacts Group at the University of Washington for a couple more months, in addition to my responsibilities with the Oregon Climate Change Research Institute. And at University of Washington, I also serve as state climatologist, and I'm pleased that you'll have Nolan Doskin, the president of the AASC, to speak in a few minutes. I've been invited here to speak on behalf of the 9 university-based, regionally focused research teams known as RISAs, which Dr. DeGaetano already mentioned. RISA stands for Regionally Integrated Sciences and Assessments, and they're supported by NOAA's Climate Program Office. Most of the RISA teams have contributed to my oral and written testimony. RISAs have been providing climate services since the first RISA, our own Climate Impacts Group at the University of Washington, was established in 1995 by Ed Miles. Indeed, our group, with Ed as lead author, wrote a paper on national climate services published in 2006 that helped start the current discussion about climate services. Climate services provide the use-inspired climate science needed to support decisions that plan for and cope with climate variability and change. With steady progress in science, vigorous growth in demand for actionable climate information, and the urgency of coping with a changing climate, the time for a national climate service has arrived. Selecting from dozens of possible examples, I provide here a few examples of climate services that the RISAs provide, focusing for brevity on water resources. Early on, the Northwest and Pacific RISAs helped agencies like Seattle Public Utilities and Pacific Island Water Resource Managers apply seasonal forecasts to estimates of water supply. Western and Southeastern RISAs have engaged in drought planning and monitoring and post-drought analysis. CLIMAS, the Southwest RISA, worked with state agencies in Arizona on the Arizona Drought Preparedness Plan. The RISA in the Carolinas developed a drought monitoring tool to monitor low flow triggers. Looking decades into the future, RISA scientists analyzed the effects of climate change on the small rivers that supply urban needs, like the Cedar River for Seattle, and on the large basins, the Columbia and the Colorado, for example. Such projections are now routinely being used in long-range planning by municipal and state governments in partnership with RISAs, as in California, Colorado, and Washington. Western RISAs have worked for a number of years with the U.S. Bureau of Reclamation and others to understand uses of climate information. These and other examples illustrate the importance of the partnerships that RISAs have with NOAA offices and other federal agencies, regional climate centers, state climatologists, extension, tribes, state and local governments, NGOs, and the private sector. Each of these partners has unique contributions, perspectives, and responsibilities. The RISAs based at universities emphasize user-oriented research and outreach. In a national climate service, user-oriented research would be vital, and RISAs would play a critical role. Here's an example of what an NCS could accomplish. Redrawing floodplain maps with a rigorous assessment of how climate change may be changing the flood risk, also known as the 100-year flood. Federal labs provide climate model outputs. University researchers run hydrologic models. Political science experts craft flexible policies to incorporate local concerns. RISAs and state climatologists and extension engage emergency managers, land use planners, and so on. Climate services are already provided in various forms by the 9 RISAs, by regional climate centers, private consultants, state climatologists, and so on, but the efforts fall short of what is needed. For one thing, the RISA program needs to be expanded to serve all 50 states, plus the territories. And funding for the RISA program is so thinly stretched now that we cannot meet user demand. Building on the 2001 NRC report, the RISAs came up with 10 key elements that we believe will be critical to an effective NCS. I've condensed it to 5 for brevity. Number 1, needs of stakeholders must be foremost and are best understood at the regional scale. 2, NCS must recognize that decision contexts need climate information and much more. 3, because capability must span a range of space scales, implementation must be national, but with strong regional and state components, including universities, to assist regional and state level decisions. 4, NCS design should be flexible and evolutionary and be built around effective partnerships. 5, NCS success requires that an effective larger national and international climate science enterprise, including observations, exists to support it. The RISAs show that regional university-federal partnerships can make unprecedented progress in providing climate services, and we succeed because we're backed up by a world-class federal science enterprise. Climate knowledge, properly used and conveyed, will help Americans deal with and indeed prosper in the face of future climate variability and change. Thank you for your time.
Chairman Baird, Ranking Member Inglis, and members of the subcommittee, thank you for offering the National Weather Service Employees Organization the opportunity to present its views on options for developing a national climate service. It is our view that the creation of a national climate service as a separate line office within NOAA is unnecessary because it would duplicate the historic and current mission, programs, and services of the National Weather Service and will inevitably result in a reduction of resources for the Weather Service. Today, nearly 1,000 employees of the Weather Service are performing climate service work as a key element of their jobs. The NWS already operates the surface and upper air observing systems that are the basis of the nation's climate record. It conducts applied climate prediction research and issues an extensive array of climate forecasts and outlooks. Moreover, the entire Weather Service workforce has integrated climate into its current weather forecast and warning activities. Therefore, the new National Climate Service should be created as an entity within the National Weather Service, or the National Weather Service should be rechartered as the National Weather and Climate Service, which in fact is a better descriptor of its current mission. Much of what a National Climate Service would do is already being done by the Weather Service's Climate Prediction Center in Camp Springs, Maryland. The CPC performs global climate modeling, engages in applied climate research, issues predictions of climate variability, and assessments of the origins of major climatic anomalies. Among its many climate products are the Atlantic and Eastern Pacific hurricane outlooks, the seasonal drought outlooks disseminated by the National Integrated Drought Information System, and El Nino and La Nina climate forecast. The CPC even provides climate forecasts that assist the USAID with famine relief in Africa, Southeast Asia, South and Latin America, and Afghanistan. Climate services are also fully integrated within the National Weather Service field organization and forecasting offices across the country, from acquiring national climatic data to producing and disseminating climate predictions. There is a climate service program at each Weather Service regional office. Each of the Weather Service's 122 forecast offices issues a variety of climate products several times a day and manages the government's climate monitoring network. The data provided by this network is used for the management of water resources, prediction of crop yields, and the study of climate variability. A number of the findings and recommendations contained in the Science Advisory Board's recent report on options for a climate service lead to the conclusion that a national climate service should be embedded within the Weather Service. First amongst the SAB's recommendations was that, quote, an internal reorganization of NOAA that enables greater connectivity of weather and climate functions is a necessary step for success, close quote. Therefore, rather than standing up the National Climate Service as a separate new agency, NOAA should consolidate the disparate climate programs in other NOAA line offices with the climate service programs already provided by the National Weather Service. The SAB also concluded that, quote, from every practical standpoint, this option is the simplest to implement, close quote. In other words, we already have a shovel-ready National Climate Service. The alternative, which has been proposed by NOAA, is to sever weather from climate by some arbitrary temporal distinction between the two, or worse yet, duplicating services and programs already delivered by the Weather Service. Not only would this be a waste of resources, but there would be no authoritative voice in climate matters. As the SAB noted in its findings, quote, the greatest strength of a combined weather and climate service are an ability to speak with an authoritative voice, build quickly from existing components of a climate service, and an ability to ensure one-stop shopping if weather and climate functions are integrated, close quote. Finally, it is not possible to transfer the ongoing climate services performed by the NWS into another line agency, since they are so functionally integrated with the day-to-day operations of the Weather Service and are widely dispersed among over 150 NWS offices. Prediction of the climate cannot be severed from prediction of the weather. Thank you, Mr. Chairman.
Thank you, Mr. Hirn. Very interesting and thought-provoking testimony. I should mention we've also been joined by Mr. Tonko. Thank you very much for joining us. I'll recognize myself for 5 minutes. Let me start by just getting a sense of what it is we have to offer here in terms of accuracy and benefits. When someone comes and says, okay, I need a climate forecast, and I thought, Dr. Barron, your testimony was very eloquent, you know, when you listed the various reasons for doing it: human health, food security, disaster preparedness, energy. Basically, every aspect of our life is in some way going to be influenced by this, is influenced by it. The question is how we are able to prepare for that. Give us some examples of where someone has, an entity has come and said, give us a climate forecast, and that climate forecast has been given and it's been beneficial economically or in human health, et cetera. Have we got some success stories?
Well, the RESAs have a number. The RESAs have a number of such success stories. One example was actually a partnership among several of the Western RESAs to cooperate with several federal agencies to come up with a seasonal wildfire outlook. There are climatic aspects to wildfire risk, and this helped position resources. And this effort has been going on for a number of years. I've mentioned water resources. Energy is another one. There are linkages up and down the West Coast on energy supply. With hydropower, we know what the fuel availability is several months in advance, just based on the snow on the ground, but using seasonal forecasts, we can expect shifts in the probabilities of that fuel even several months in advance of that. I could give you many other examples.
That's a good start. Dr. Barron?
I was going to add, for example, that major cities in the United States, notably New York City and Chicago, both have developed climate plans that are influencing their decisions about infrastructure renewal, because that infrastructure is required to exist for many, many decades.
If you build something that may one day be below sea level and you need it to be above sea level, that's a problem.
Or for which the water resource will change, as another example.
Excellent points.
Mr. Chairman, can I expand
Please.
on that? In New York, we're also looking at extreme rainfall, like Dr. Lubchenco mentioned earlier. We're not looking at just the big rainfall events, but kind of relating those to what we stormwater recharge or runoff in any of our cities. It is that the stakeholders actually base their decisions on, and providing them data based on the trends we have seen in the past years.
You're giving them predictions. This is what we think is likely to happen over the next 10, 20, 50 years.
Correct. The administrator also alluded to that in her discussion, that the state of the art as far as climate modeling is not enough to make those projections accurately out into the future. So in that case, we do have to rely upon the trend that we've seen to give some uncertainty in how to do it. If you're looking to build infrastructure that has a lifetime of 50 years, You don't want to go into that decision blindly based on just some static record that's assumed to be stationary.
Let's go into then this issue of if we acknowledge that there can be benefits from this, let's talk a little bit about possible structures for this. We've heard Mr. Hirn suggest that maybe he would assert, his organization would assert that the Weather Service is basically already providing this. It needs to be possibly given that title and acknowledgement. Others have said there needs to be a separate or coordinating entity that coordinates the various elements, perhaps Weather Service with the REISs, et cetera. What are the pros and cons of the different models? And I'm going to leave that somewhat open. And Dr. Barron, I thought you were suggesting, you acknowledged a high level, possibly OSD. I don't know if you said OSTP, but it sort of came to my mind, and Dr. Lubchenco mentioned it. But then it sounded like you talked about a nonprofit third entity, and let's talk about the pros and cons of that. Dr. Barron, talk about that first, and then if somebody wants to respond to Mr. Hirn's suggestion, pros and cons of that, and vice versa.
Okay, so I really think that we need many facets. One of the things that came out of the option report is none of those options were perfect. So for instance, you may be able to stand up something quickly in NOAA, but how does NOAA partner with all of those other federal agencies? That requires something that's quite different in order to ensure that everybody is participating. We've seen a lot of examples where we've created something like a national carbon program. But then if one agency, because of other competing missions, doesn't involve themselves in it, it starts to fall apart, and it's no longer even close to what it is that you had set up. So it cannot just be adding climate to weather. I think that's a rather different topic. So that's one element of it there, to have that integration at a federal level, and I think as high up in the structure as possible, and OSTP certainly makes sense. But I think there's this other sense that we have a lot of users that cross all these boundaries that we're talking about. So should every city have to redo the research themselves? Or if you're sitting there looking at oil rigs offshore in many, many different states, can they all sit there at the table and work together and generate the research that works on that? Or if you're looking at hurricane forecasting, do you have that capability? You wouldn't want to regionalize that. And so I think there was a sense among the options committee that an entity, a nonprofit, a facility, a center that promoted this in terms of research and connecting to users was something that's important. There are many users out there that have a sense of what they want. And if you throw the data over the transom, they'll go grab it. There are many, many other users who haven't realized the potential here yet. They're beginning to think about something. It's in 3 or 4 different places. They need some capability to integrate that. So my feeling is this isn't a single story here that we have to facilitate.
So we're not necessarily it's not like we're asking for what is the one climate prediction, but what is the source one goes to gather the multitude of perspectives.
And where do you go for help?
Yeah. Mr. Hirn?
Well, I have some concerns about this nonprofit federation that is outside the government. I question of how much oversight that this committee and other congressional committees would be able to give to that. I fear that that is just going to become a source of earmarking or maybe a source of pet projects as time goes by, and would rather see it being done by a federal agency that is responsive to the public and the Congress. I note that in Dr. Lubchenco's written testimony and certain public statements she's made, she's talked about making it, using the National Weather Service as a model of private and public partnership for this National Climate Service. NOAA has not yet answered to anyone, and nor to the employees of the Weather Service, why would you use the National Weather Service as a model for this rather than just continue to use the Weather Service for actually carrying it out, much as they do today.
Recognize Mr. Inglis for 5 minutes.
Thank you, Mr. Chairman. I'm still wondering about whether we're creating overlap here and how to make this most efficient. And as I understand it, I really am sort of unclear, so maybe you can help me understand the difference between what the work of the REISs and the regional climate centers and the state climate offices, they work together, but they don't provide the same services. So I wonder, are all three needed, or how much duplication is there between those three, the REISs, the regional climate centers, and the state climate offices?
Can I respond, Mr. Inglis? I was actually going to respond the same way to the previous question. One of the problems with having a large federal entity, be it a nonprofit or the Weather Service, kind of a place to go, is that the other side of climate services is the other way around. It has to be active. What we've seen in any number of years, in a lot of cases, like Dr. Barron said, you can't just throw the data over the transom and have people come to them. But you actually have to actively go out and seek out these people and talk to them. A good example is our work with West Nile virus. You know, it was us going out and speaking to the people from New York City who control the mosquito population, public health officials, where we got the understanding of what were the climate issues in this problem. It's very hard to do that from one place, be it regional, be it national. When you get down to the state level or even the local levels than that, that's where those trust-based relationships are. You can think of the service as almost like a funnel where that information comes up, those ideas are generated, but when the service becomes operational, when data go out, when models are developed, we have to make sure that these are all being based on the same data, the same models, the same ideas. That's where the regional comes into play. You can think of it almost as the airline system, where perhaps the regional area is the hubs, and the state climatologists are the individual airports, and maybe the National Weather Service or some federal entity is the overarching company. That climate services work very much in the same way.
If I could respond as well, the Western REISs all have very good relationships with the Western Regional Climate Center, and I think we have sort of worked out a division of labor that there is very little overlap.
What is that division of labor? How does that work?
I would say that, and Dr. DeGaetano can correct me if I'm wrong, but I would say that the regional climate centers are best at understanding the climate data, the observations for the region. They typically do not, at least the Western Regional Climate Center, doesn't do a lot of work, say, with global climate model outputs, scenarios of future climate. That's the same is true of the Weather Service. Their climate focal points are not trained in dealing with some of these longer timescale issues. The REISs, based at universities, are focused on innovation, publishing research papers, coming up with new ideas, not so much operational. So we have developed things that we've handed off to, for example, the river forecast centers within the Weather Service, or the Water and Climate Center within U.S. Department of Agriculture's Natural Resources Conservation Service. Now, the state climatologists are best at having those relationships with individual entities within their states. And your state climatologist, Hope Mizell, is an excellent state climatologist. She's developed a lot of great products for the state of South Carolina. Those are things that are supported by the Southeast Regional Climate Center and informed by what is needed locally. So the state climatologists are really listening locally. A lot of this is not about, as Dr. Barron said, we don't just generate climate knowledge and throw it over the transom. We are actively listening to what people need and responding.
Anybody else? Dr. Barron.
Well, I just want to point out that despite all these different components, it's still not good enough. And one of the reasons why it's not good enough is because these teams are small enough that they have to focus on particular areas, and therefore they can't address the broad range of users. And it's very hard to cross from place to place. So what I see as one of the really good examples is in the 50s we discovered that with computers we could predict the weather, and we're getting pretty good at it, to the point where we close schools and do things in advance of a particular storm. If you take the human health community, they almost always react to the number of cases that came in the door. It's very rarely a forecast or prediction. Yet so many different parts of human health are now tied to environmental conditions that if you can predict environmental conditions, you can begin to predict adverse human health outcomes and save an enormous amount of money. Do I put that in a state? Do I put that in a region? It requires something that's quite different from that particular component if we're all of a sudden going to realize the fact that out 15 years, we'll be doing human health forecasts just like we do pollen alerts and air quality and weather forecasts. But we don't have anything in place that allows those communities of users to intersect with this environmental prediction, climate modeling, weather forecasting groups, just as an example.
Thank you, Mr. Chairman.
Thank you. Ms. Woolsey.
Thank you, Mr.
I should
Chair.
mention we've been joined by Ms. Edwards as well. Thank you for joining.
Thank you, Mr. Chairman. I would like to leave some time for the rest of the panel to respond to the chairman's question, but before I do that, I'd like to make a comment. Wouldn't it be something if climate change became news like weather is now, because we actually, with the National Weather Service, kind of can see what's coming and why it happened and when it's going to happen? I think it'd be very good, because then the people of this country would see it as news and not just as something that happened to them that they have no control over. And I just think this is all leading us in the right direction. And I know that Chairman Baird wanted more. I thought that some of you wanted to respond to Chairman Baird's question, his open question about why we need to do this and what's a better way. And as you're answering it, if you could, for me, talk about if there's opportunity for international cooperation in our get-along here. So I'm doing part of your job for you. I'm yielding to finish your question.
I appreciate that, actually. I would have appreciated more time, but in deference to my colleagues, I gave back some. But thank you, Ms. Woolsey.
Ms. Woolsey, I recently had a visit to the Climate Prediction Center in Camp Springs, I believe in Congresswoman's Edwards' district. I was visited what they call the Africa desk there, which I was extraordinarily impressed. They do climate forecasting for Africa and other third world areas of the third world, helping them with their drought predictions. But what I found was most remarkable is I met a number of meteorologists from Malawi and elsewhere in Africa, that the Weather Service brings 12 meteorologists a year from Africa for a 4-month residency at the Climate Prediction Center and teaches them, trains them in climatology to go back and work on drought prediction, things like that.
Well, good. That's very, very interesting, and that's and let's get up to the doctors here who didn't get to answer the chairman, and maybe we'll have time to talk some more about those people, the Africans that came.
I think there's tremendous opportunities for that. And the thing that we need to look at is exactly getting down to the regional scale, not looking at these broad global problems, but actually bringing data and projections, or even looking at data down to regional levels and starting to interact with stakeholders. It may not be that we can make a prediction or a forecast on what the climate will be like in 2100. But to bring people along to see the types of things that they have to start concerning them about, to make them more resilient to the types of climate variations we see today, will only make it stronger in the future when the modeling and capabilities are able to come around to make those projections at regional levels.
Dr. Barron?
You know, I think the ground is so fertile to do so many things that are beneficial, or to at least have reasoned answers for particular actions. And you can look at one example after another. We're watching the Rocky Mountains being ravaged by the pine bark beetle. First time that I know of, leave only a footprint, take only a picture, we've used insecticides in Rocky Mountain National Park as an example. So now when we watch these trees go away, do you leave it? You plant the same tree again? Do you plant a different species, or more resistant species? This is a decision we're going to have to make one way or another. It would be nice to be able to integrate climate in there. If you look at hurricane forecasting, everybody's talking about are hurricanes becoming more intense or not intense. Climate models actually don't simulate hurricanes. They don't simulate hurricanes because we don't have the the power to get the climate models down to a resolution to simulate them, so important for so many coastal states. If we can embed weather forecast models and climate models as part of a regional emphasis on climate, something we're not doing today, we'll actually be at the point where we're simulating hurricanes out decades in a row. Sea ice is melting around Alaska. We're watching native village peoples have to be moved. How many times would you like to move them? Do you sit there and decide in advance to move them slowly? Do you do it in one particular lump as the sea ice is gone and the waves start pounding the coast and in the buildings go? It seems to me it would be nice, and it's a relatively small investment when you consider the costs of moving infrastructure, to sit there and try to do this in some particular intelligent manner. The Colorado River Compact was one that was negotiated based on a time period of rather abundant rainfall. Will we have to look at this again? And wouldn't we rather do that instead of looking at a limited record with some larger understanding of climate change? So I think it's just an enormous potential if we can start connecting climate to society.
Okay.
Thank you, Ms. Woolsey. I appreciate you following that line of questioning. Having grown up in the Colorado and studied in the Colorado River Basin, entire basin ravaged for years by political infighting that grew out of having, as I understand it, divvied up the water in a fairly record high water year, and so promising water that didn't then later exist. And it's been really years and years and years of litigation and conflict and inadequate water supply. I'll recognize Mr. Tonko for 5 minutes.
Thank you, Mr. Chair. Dr. Barron, you touched upon this in your most recent response, but I represent a district that has many communities along an historic waterway. The advantages of a system that is optimum, as you would define it, be it state, regional, and national in design. How can we emphasize prevention to avoid certain flooding, and then how can we respond in mitigation terms? You know, what would you envision to be the modeling out there that would enable communities to better avoid floods and then to better respond to floods? How would that infrastructure work? Because it seems to be a repeated pattern with the extremes of climate change, that more and more communities are impacted by flooding of rivers in intercoastal waterways.
Yeah, so I gave the example in human health to think broadly and cross regions, but I think an example that you've just selected, it points to how important it is to have a community of scientists to interface with that are local and regional, because so many of those examples are examples by which the way you build infrastructure makes an enormous amount of difference in terms of your vulnerability. And I think that this whole notion of building resilience into communities by understanding this makes an enormous amount of difference. So this is where the system needs to couple that on a global scale and a regional scale, and understanding how the system might change through global models and coupling those with weather forecast models, but taking yourself right down to that local and regional level, because all of these problems, when you come right down to it, are local. But we're now being affected by local decisions as well as global decisions.
I was just going to ask if anyone else has a response to that.
If you mind,
Okay.
I missed the last round. I'd like to emphasize that in addition to better modeling to characterize the physical system, which both I and Dr. Barron emphasized earlier, we need vigorous social science research to understand how decisions are made, the decision context, how to provide information that's actually useful and will be used to make better decisions. And this is a component of this whole enterprise that is, and I say this as a physical scientist with a degree in physics, this is a part of this that is greatly neglected in the current climate science enterprise.
If I may. Actually, your question was pretty timely, because Monday be traveling to Norrie Point, which is either in your district or just south of your district, to address that very issue. We're working with DEC and a number of entities within New York State to look how sea level rise will manifest itself up the Hudson River, to look at infrastructure along the river, to look at different control mechanisms that might be put in place between up the river, a true interdisciplinary effort between hydrologists, social scientists through the Rising Waters Program, which is out of the Hudson River Estuary Commission. So those types of things are things that any of our organizations are involved with and are starting to work with now.
So the model that best coordinates all of that would look like what? Is there, who brings all the agencies that obviously have to have input here together, and then how is it connected to the local planning or response effort?
I'm probably not the best one to say who brings all the agencies together, but I think this is a good example of how the system needs to work. For instance, you need the local knowledge and expertise to know what's going on the Hudson. You need the local expertise to do the modeling of what's going to happen in the Hudson River basin. The basin, the hydrology is very different than other river basins, so you can't just take some river model off the shelves. So those are the local components. On the national scale, do you use my sea level rise projection or do you use somebody else's? There you need the coordinating efforts to make sure the data, either the observed data or the projections that go into these types of things are consistent, that those types of things that come into play are there, that authoritative voice to say that this sea level rise projection or this suite of sea level rise projections manifests themselves this way on the Hudson River and has this implication.
Thank you.
Thank you, Mr. Tonko. Dr. Mote, I appreciate your observation about social science. As my colleagues know, I'm a social scientist, and I was down at AOML a couple of years ago, and they were talking about the need for more supercomputing to predict hurricanes. But someone pointed out that even if basically we were pretty good at Katrina, but magnitude, timing, location, pretty accurate. But even if we had to the date, the moment, the magnitude, 50% of the people still wouldn't evacuate. And that's a social science problem, so I appreciate you raising it. Ms. Edwards is recognized for 5 minutes.
Thank you very much, Mr. Chairman, and thank you to the panelists. I'm sorry I actually missed Dr. Lubchenco earlier because I had a chance to spend some time with her out at NOAA to learn in a lot more detail about the work that's going on there, both in weather forecasting, but also the range of work that the agency already does in climate, and was really impressed by the work going on at that facility and the others around the country. My question really for Dr. Barron is is to ask you that given what may be deficiencies or inadequacies in the current wide range of climate activity going on across the spectrum of the federal government and the private and academic sector, if NOAA were to retain the role of or gain the role of essentially the federal kind of coordinator of climate service activities, what do you think would be the essential thing that needs to change within NOAA to be able to take on this activity? And I'm also curious to know what you think NOAA's strengths are in being able to gain that responsibility.
Okay, in many ways, I think NOAA is a natural lead, as I said, because of both their current effort in providing services and because they have pieces here that they fund, National Climate Data Center, the RISAs, and those activities. The reason why our group said it's not enough is because I'll give you just one example, and that is that if you go around the table, and I had a meeting with OSTP in which 40 people representing 15 agencies were there, resource managers, they were asked the question, what do you need first? And they all said regional climate predictions. Those become essential because they get closer to the decisions. Now, we don't have the compute power to do a very high-resolution global climate model, but we have the capability to embed weather models within climate models and then provide, with that global model input, a weather forecast 30 years out, 40 years out, not stating a day, but those conditions would yield this type of weather, and we could simulate things like hurricanes. So we know we're going to have to couple those capabilities, and within NOAA, these are quite separate. So we have to find a way to have the conversation occur within NOAA that helps promote a synergism between the modeling components. That's one example. The other example I think we see is that that connection to users is now being done through a RESA or providing data that's sitting out there that a private company can grab. And we're going to move into a climate mode where private companies are going to want to grab that data. But there's also an enormous number of things by which that whole community hasn't had decades of weather forecasts to be able to say, oh, I'm interested in that. That will affect what I want to do on this particular.
Let me just interrupt you because I think those things may be true, but it seems to me, and others, have an opportunity to comment on this, that some of that is also a resource question and a need to coordinate information and data, and so it's not so much about where the house is, but what the pieces need to be. What's the structure? And I look at, for example, on Weather Service, and thinking only in my lifetime, the evolution of how we've come on Weather Service, where we've been able to get down to that regional level, where people, if you talk to them in communities, maybe it's not such a bad idea that they think that their local weather person is the weather predictor. That's just because the information has been made usable and accessible, and so. I don't know that there's anything that is an institutional barrier within NOAA that would not enable us to thoughtfully figure out a way to bring that under a house so that our weather and our climate predictions and forecasts are connected. And I wonder, in my limited time left, if there are others on the panel who have a response to that.
Well, if I might, it really needs to be all about the users. So it's not just about providing information, and there are many other agencies that are responsive to the users, and so it really goes beyond NOAA. I agree with Dr. Barron. There needs to be a really high level multi-agency partnership.
Mr. Chairman, I'll yield, and I will just say, just in closing, that it does seem to me that as we go forward for this Congress to provide the kind of oversight that we need to, it will be very complicated, I think, for us reaching over several different stretches of the federal government to figure out who's on first.
I appreciate that. And I think, gentlemen, you're probably getting a sense from the committee. We recognize fully, and I think your testimony and that of Dr. Lubchenco has really illustrated the need and the value for this information. I think there's an appreciation on the part of the committee members that, based on your testimony, that it needs to be better integrated, better distributed, better coordinated, et cetera, that there are multiple different entities within the government that are now doing parts of this. I think that what we're all struggling with a little bit, I think was in line with Ms. Woolsey's question and Ms. Edwards as well, is how does it all fit together? If you, and the bottom line for us is, if we write a bill, which we intend to create some form of climate service, what should that look like? Where do the pieces fit together? How is it coordinated? And we have another panel. I think Dr. Mote and others have talked about the importance of users. We'll move very shortly to the next panel. But I would invite you to do this. So often in these committees hearings, and it's true throughout the Congress, what happens is we ask you for your testimony, we ask questions, and then we don't see you again for a really long time, if ever. And you don't necessarily always get to follow up with input about what other panelists suggested. So I would invite you to give us follow-up testimony, if you will, based on, if you feel need to further elucidate the questions we ask you, or to respond to what a colleague on the panel may have said. Say, here's, so-and-so said this. This is where I agree, this is where I disagree, here's an alternative synthesis or divergence. Please do that for us, and if you can do it in a very timely manner, that would be most appreciated, because my hunch is you've all spent a lifetime working on this. We've read the testimony, we've had this discussion. We want to do something right. We want to follow the dictum of do no harm, we believe something needs to be done. So if you can follow up in that fashion, it would be most appreciated. And unless anyone has any burning issues for this panel, and we may submit to you, it's customary at the end of these hearings to say the record will be open for 2 weeks. We may also follow up and say some more honing in points on ideas on this. With that, I want to thank our witnesses for a very informative and thought-provoking discussion, and for your many years of service, all of you, in your respective roles on an ongoing basis that have helped serve the country and this Congress and constituents. We'll adjourn this, we'll excuse this panel and invite the next panel up, take a very, very brief break while the names are switched around by our capable staff. Thank you again.
One of the climate change reporting should be as regard.
I'll ask people to retake their seats, and we will begin very, very shortly with our third panel. I appreciate your patience, and I think it's a very constructive structure we have here, I hope, with the folks who provide some of the information and some of the recipients and utilizers and people who apply that. And that's the main focus of panel 3. Let me introduce that panel. Dr. Michael Strobel is the director of the National Water and Climate Center for United States Department of Agriculture. Mr. Paul Fleming, the manager of the Climate and Sustainability Group for the Seattle Public Utilities. Dr. Nolan Doskin, or Mr. Nolan Doskin. Did I say the last name right? Duskin, thank you, Mr. Duskin. The state climatologist for Colorado and a senior research associate at Colorado State University, the alma mater of my father, by the way. Spent some time in Fort Collins. And I would now like to recognize my friend from California, Representative Lynn Woolsey, to introduce Mr. Bihar.
Well, Mr. Chairman, I'm going to take a lot more time on Mr. Behar than you did on all these together. Is that all right?
Well, that's sort of the custom here, is when you
All right.
introduce some of the local folks, you get a little extra.
My guy, I work for him, so I'll take better care of him then. Mr. Chairman, it's my pleasure to introduce one of my constituents, someone I work for in my district. He's here today to testify before our committee. His name is Mr. David Behar. David's career spans over 20 years in environmental policy and water utility management. He currently serves as deputy to the Assistant General Manager, Water Enterprise at the San Francisco Public Utilities Commission, the SFPUC. Mr. Behar developed the SFPUC-sponsored Water Utility Climate Change Summit held in San Francisco in early 2007, and he currently serves as staff chair of the Water Utility Climate Alliance. From 1991 to 1997, he served as executive director of the Bay Institute of San Francisco. And from 1989 to 91, he served on the staff of U.S. Senator Alan Cranston, a Democrat from California. In November of 2006, David was elected to the board of directors of the Marin Municipal Water District, a district with 200,000 customers just north of San Francisco in my district in Marin County. David lives with his two children in Marin County, and I'm pleased to welcome him here today in Washington, D.C.
Thank you, Ms. Woolsey. I appreciate that. We all serve all these people, whether or not we are privileged to have you in our district. We are honored to have you here today. We'll proceed in questioning and witness statements from Dr. Strobel across through the panel. With that, I'll begin with Dr. Strobel. Thank you.
Good morning, Chairman Baird, Ranking Member Inglis, and other members of the subcommittee. Thank you for the opportunity to testify today about the climate data collection and analysis activities of USDA's Natural Resources Conservation Service. My name is Michael Strobel. I'm the director of NRCS's National Water and Climate Center in Portland, Oregon. NRCS has been a leader in climate services to assist agricultural activities and natural resource conservation since 1935. In that year, the Soil Conservation Service, which NRCS was then known as, established a formal cooperative snow survey and water supply forecasting program. The snow survey program has grown in scope and in number and diversity of users that rely on the water supply forecast developed by NRCS. In addition to the snow survey program, the National Water and Climate Center also manages the Soil Climate Analysis Network, or SCAN, a soil moisture and climate information system designed to provide data to support natural resource assessments and conservation activities. I will briefly discuss SCAN later, but I'll spend the majority of my time discussing the snow survey and water supply forecasting program, how it works, why it's important, and who uses that information. Depending on the geographic location, 50 to 80% of the annual water supply in the West arrives in the form of snow. The NRCS's snow survey program is a main source of data on high elevation snowpack in the West. Data on the depth and density of the snowpack provide critical information to decision makers and water managers throughout the West. NRCS works hard to ensure that consistent and reliable water forecasts are available for a wide variety of uses throughout the year. Since 1935, the snow survey program has grown into a network of almost 2,000 snowpack monitoring sites in 13 western states, including Alaska. More than 1,200 of these sites are manually measured snow courses. Either an NRCS employee or an employee of a partner organization must visit each manual snow course site once a month during the snow season and take snowpack measurements manually. The remaining 760 sites are automated snowpack telemetry, or SNOTEL, climate stations, which do not require monthly visits but provide real-time snowpack information via media burst technology. In the future, we'll continue to increase the percentages of snow survey sites that are automated. This would result in more accurate water supply forecasts and snowpack reports, as well as a decrease in the safety risks for NRCS employees and partners who monitor remote sites in what can be sometimes challenging winter conditions. NRCS employees use the manual snow course and automated SNOTEL data, as well as modeled water supply and streamflow volume data, to develop streamflow forecasts for over 740 locations in the West. These forecasts help reduce the uncertainty for users making everything from long-term strategic decisions regarding multi-year water supplies to immediate emergency response decisions in times of high stream flows. Let me give you a few concrete examples of how our customers use our water supply forecasts. Agricultural producers use our forecasts to manage drought risk, make cropping decisions, and determine irrigation allotments. Wildlife conservationists use stream flow forecasts to help manage habitat for threatened and endangered species. Climate researchers use snowpack data to develop climate change risk assessments for long-term water availability. Municipal officials use snow survey data and analysis to manage reservoir levels in western towns and cities. The National Weather Service's river forecast centers depend on snow survey data for snowpack component of their data analysis and forecasting systems. And recreation is a key industry in the West. Ski resorts, river rafting companies, and others use our data and forecasts to operate and manage their facilities. I hope I've given you a sense of the number and diversity of end users that rely on our snow survey and water supply forecasting information. The National Water and Climate Center also manages SCAN, the Soil Climate Analysis Network, which was started as a pilot program in 1991. SCAN has evolved into a cooperative system that monitors soil moisture and other climate parameters and makes the data available to users on a real-time basis. The system is used primarily for monitoring and mitigating the effects of drought and flooding. The current SCAN system consists of 150 stations located in 39 states across the U.S. In summary, NRCS's climate services produce critical data, forecasts, and analysis for a wide variety of public and private uses. Users rely on NRCS's near real-time data and unbiased forecast to plan and execute short and long-term decisions ranging from individual farmers' planning dates to basin-wide water management planning. Thank you again, Mr. Chairman, for the opportunity to appear before you today, and I'd be happy to respond to any questions.
Thank you, Dr. Strobel. I envy your work. I'd love to spend some days up looking at snow sites from time to time.
It's a great job.
And you do great work for the Northwest. I'm grateful for it. Thank you. Mr. Bihar.
Thank you, Mr. Chairman. Thank you, Ranking Member Inglis, members of the committee, and of course, Congresswoman Woolsey. Thank you very much for that introduction. I will go back and report to our constituents who know and love and respect your work very much that you are on top of climate change issues as you are, and that matters so much to all of us in Marin. I appreciate the opportunity, Mr. Chairman, to come and speak from a stakeholder perspective about the need for a National Climate Service. I've been introduced. SFPUC has 2.5 million water customers in the Bay Area. We're the 6th largest municipal water district in the country. And as Ms. Woolsey mentioned, we're also a founding member and coordinate the Water Utility Climate Alliance, which is a consortium of 8 large water utilities from around the nation, serving more than 36 million customers. It's focused exclusively on adaptation, the adaptation challenges we face in the water industry. According to 2 recent EPA reports to Congress, water and wastewater utilities together will need to spend about $480 billion over the next 20 years or so upgrading our systems to keep them in a state of good repair. The figure does not include responding to climate change challenges, but we know that all of those investments in new assets will be made as our climate is changing. However, as has been mentioned, many of today's climate change projections are so uncertain as to be difficult to use in planning how we purchase those assets and planning how we spend those funds on our systems. And that's why when it comes to climate change science, water utilities are looking for what WUCA members have begun to call actionable science. We define actionable science to mean, quote, data analysis and forecasts that are sufficiently predictive, accepted, and understandable to support decision-making, including capital investment decision-making. The term is intended to convey our understanding that perfect information on climate change is neither available today nor likely to be available in the near future, but that over time, as the threats climate change pose to our systems grow more real, predicting those effects with greater certainty is a non-discretionary choice that we need to make. Now, if actionable science is one need, accessible science is another need. A National Climate Service, we believe, can provide access to science to those of us who are assessing our vulnerability in an accessible fashion. I want to agree strongly with Dr. Barron, who said that from a stakeholder perspective, it can be difficult at times to get the kind of climate information that we need to plug into our operations models and begin to think about what our adaptation challenges actually are. I've seen from my experience at both the PUC and as a director at MMWD how difficult it can be to access sound science and to know what it is you're actually accessing. Even relatively sophisticated water agencies are having difficult time answering the most basic questions related to what climate challenges we actually face in the long term, which is the asset investment strategy that we have to think about. I want to also commend Dr. Barron and the Science Advisory Board that NOAA asked to put together its options for developing a National Climate Service report. The report identified key attributes of a National Climate Service that I think are worth citing for a moment. It said, the service will achieve its mission by promoting active interaction among users, researchers, and information providers. The service will be user-centric by ensuring that scientifically based information is accessible and commensurate with users' needs and limitations. This has been echoed in some of the testimony so far you've heard today, and I want to agree wholeheartedly with that. In our view, a powerful and responsive National Climate Service should be like a wheel, with a hub, which is our headquarters, and spokes, which are regional centers. Like a wheel, without the hub, the wheels come off. At the end of the spokes is where we think the rubber is going to hit the road. At the center, we need a federal family to come together and create a cohesive federal structure that supports the NCS mission. We want to see lessons learned from the example of the U.S. Climate Change Science Program, which has produced a tremendous amount of important research, but has at times been criticized for failing to achieve a consistent and transparent vision for that research, and also for struggling at times to effectively engage the stakeholder community. At the spokes of the wheel, stakeholders and researchers alike strongly believe that the success of an NCS mission, as others have said today already, depends on creating a robust and geographically distributed regional presence. Such a presence would feature engaged, multidisciplinary teams of physical scientists, social scientists, communications specialists, and modelers that are located in the communities that are facing adaptation challenges. Those boots-on-the-ground experts understand their region and its unique conditions and are active participants in ongoing conversations with climate information users, folks like ourselves. And they aren't paratroopers, just to stretch the military analogy to its breaking point. They are actually part of the community, the communities that they serve. This decentralized user-centric approach is far from unprecedented in the federal government. Many have talked about the RISA program. We agree that it is a model that can be expanded upon, improved even, made broader with a more consistent mission across the United States, and perhaps provide a model for that geographically distributed approach that we think is so essential to reflect user concerns over adaptation and bringing climate science out to our communities. Thank you very much.
Thank you, Mr. Behar.
Good morning, Chairman Baird, Ranking Member Inglis, and members of the subcommittee. Thank you for this opportunity to testify before your committee today. My name is Paul Fleming, and I am the manager of the Climate and Sustainability Group at Seattle Public Utilities. Seattle provides reliable drinking water to 1.3 million people in the greater Seattle area and provides sewer, drainage, and solid waste services to Seattle residents. The City of Seattle has made addressing climate change a top priority. Our mayor, Greg Nichols, has been the leader in an effort to engage other mayors across the political spectrum on the issue of climate change and the need to take local action. In addition, the city's municipally owned electric utility, Seattle City Light, will likely see significant impacts to the hydropower-based operations as climate change affects our region. They both support my testimony here today. Seattle uses, relies on, and supports financially several monitoring and forecasting services provided by federal agencies such as NOAA, U.S. Geological Survey, and the Natural Resources Conservation Services to inform our real-time decision-making and short-term planning. As Dr. Mote noted, Seattle has also engaged with NOAA's Regional Integrated Sciences and Assessment Program, RISA, to assess the projected long-term impacts of climate change on our water supply, and we have used this research to develop initial adaptation options. Our operational and institutional capacity have benefited from this engagement. As an active user of several federal services and as a partner and collaborator with numerous federal agencies, Seattle believes there are potentially great benefits associated with the creation of a national climate service. We view NOAA's RISA program as a potential model, particularly given its distributed geographic structure. If it were to serve as a potential framework for a national climate service, the RISA model, however, would need to be strengthened and expanded along the following lines. One, it would need to involve multiple federal agencies in the provision of services. The water sector uses the services of, interacts with, and is regulated by many federal agencies. Our interaction with the federal family would be facilitated by having the relevant agencies coordinating their climate change programs and research through a national climate service and by viewing it as an authoritative source of climate information. 2, the National Climate Service should involve multiple sectors in the development and implementation of programs and services provided by the service. The water sector is engaged on the issue of climate change. A National Climate Service should recognize this capacity and view the water sector not just as an end user, but as a partner as well. For example, industry research groups such as the Water Research Foundation should play a critical role in conducting applied research for the water sector. 3, ensure there is consistency across the distributed structure. A National Climate Service should have a common set of goals and objectives so that the distributed branches are coordinated and emanate from a common trunk. 4, increase overall funding for a National Climate Service while maintaining and expanding, if necessary, existing monitoring networks and forecasting services. 5, build upon existing partnerships that are effective in delivering services. For example, Seattle has partnerships with the U.S. Geological Survey and the Natural Resources Conservation Service to support the ongoing operations and maintenance of stream flow and snowpack monitoring infrastructure. This infrastructure should be expanded, and a National Climate Service should build off of what currently works. In addition, I would encourage a National Climate Service to be established in such a way that allows for an option to scale the services beyond the U.S. As the federal government continues to engage internationally on climate change, there is great potential for the U.S. to assist other countries in identifying the projected impacts of climate change and enhance their adaptive capacity. In so doing, we may also address potential national security issues. In closing, I want to reiterate a few points. Large utilities in the water sector are engaged to varying degrees in furthering their capacity to understand and prepare for climate change. Given the operational knowledge and institutional capacity of the water sector, a National Climate Service should involve the water sector not just as an end user, but as a partner. A National Climate Service should serve as a vehicle to coordinate the climate change programs of the numerous federal agencies that are involved in this issue. Thank you again for the opportunity to testify this morning, Mr. Chairman and members of the committee.
I'm used to extemporaneous stuff, so wish me luck. Mr. Chairman, Ranking Member Inglis, committee members, I appreciate this opportunity to represent a state perspective on climate services. I'm the state climatologist for Colorado, the current president of the American Association of State Climatologists, and here's a little description of what we do. We are experts on the climate of our own states, whether it's just basic temperature precipitation patterns, seasonality, geographic variations, year-to-year variations, which are a really big deal, drought and other extremes, which are a really big deal, and historic trends, which are very interesting. Perhaps more importantly, we see how the climate affects the citizens of our states, their lives and their livelihoods. We rely on data, quality representative observations of our climate system, whether it's temperature networks, humidity, wind, precipitation, very important, solar energy, all of the elements of our climate system. And our ability to provide useful information to our states really relies on the presence of quality data. Whenever I travel, I see climate services in action, the infrastructure that we drive on, our bridges, our culverts, our energy distribution systems, our buildings consuming energy to keep comfortable inside regardless of the variations outside, and how we utilize what we know about our climate to better adapt our infrastructure. We've traditionally relied on federal sources for the data that we use in what we do. National Weather Service Cooperative Observer Network, very important. Airport weather observations through many decades. U.S. Geological Survey streamflow data, NRCS, which we've heard of here today, soil moisture measurements, mountain snowpack data, streamflow predictions. We're longtime users of NOAA data resources in so many ways. We basically believe the climate monitoring activities are predominantly a federal responsibility, but more so we keep seeing our fellow states doing more data collection on their own to address their own state-specific needs. At least half of us as state climatologists are involved in some way in our own data collection systems, often for agricultural purposes, also for energy, water resources, et cetera. Let me talk briefly about collaborations, because if you knew what our state budgets were, and you probably do, we can't function well without collaborations, rich collaborations with federal partners. Many of us work closely with our regional climate centers. We know them as friends. These groups have helped us stream our data access and management so we can focus on interpretation of information and the delivery of that information. A few of us have the benefit of working with RESAs. I'm one of them in Colorado. Not all states have RESAs. Many of my fellow state climatologists have no experience working with RESAs just because they're limited in geographic extent. Unlike RESAs, who get to focus on specific sectors and decision makers, we get to work with the whole gamut, anywhere from state government down to small business and individuals. Private companies are pretty good friends with state climatologists. We provide information that really helps them make their business decisions, and we're not viewed as competition. National Weather Service long partners data collection and more recently in data services. And our organizational structure that facilitates working with the federal government is our association, the American Association of State Climatologists, just as a vehicle for two-way communications. It's a little more efficient. In summary, we're local experts. We work at the grassroots level. We're an essential branch of climate services as they are occurring today. We track the pulse of our climate at the local level, and we do so on with very few resources in so many ways. We're trusted advisors to state and local government, business, individuals, and communicators of information to our local media. We're flexible and we're responsive. We're largely educators. 80% of us are at public universities. Many of us teach students, mentor grad students, as well as aid in decision makers. More than 60% of us are at land-grant universities and utilize the infrastructure and wisdom of our traditional system of extension to reach broad audiences. So we favor the concept of a national climate service. We're ready to help. Thank you.
Thank you, Mr. Duskin, and thanks to all the panel again for your insightful testimony today, but also your service. So I'm trying to envision the organizational chart in my head, which is maybe some of what we've been dealing with on the panel. And it's evident to me that you represent users, but also producers of information. It's clearly a two-way system where you can say our experiential data feeds back into the loop and vice versa. Does it make sense to come up with, if you had a national climate entity service, does it make sense that you would look at some of the various agencies that you have described already, like NRCS, like USGS, like the Weather Service, like the RESAs, and others, doubtless, and say, okay, so the National Climate Service, maybe those entities continue pretty much as they are, but the National Climate Service is the coordinating entity that brings their data together, and that to some extent the sub-agencies maybe have people with dual assignments or dedicated missions, so you know they answer sort of both chains. What about that idea? Bad idea, good idea? Does it make sense? Is it what's already being done, but there's the lack of the national coordination? What are your thoughts on that?
I'll start. I think from a stakeholder perspective, having that kind of one-stop shopping approach that leverages the data and information, leverages the expertise that exists, and leverages the regulatory and operational relationships that we already have with entities like GS and Bureau of Reclamation, if we're in a reclamation basin, is really important. It really will help to translate the climate change challenges to the user level. We need ideally a single or a few places that we know we can go to get the data, the analysis, the research assistance, and all the other inputs that go into, in the case of a water utility, in most cases, our systems operations models, so that we can then think about what it is we face in terms of our water supply. Then down the chain, we also probably could use some help from social scientists and others who are evaluating decision support methods that can be used in an atmosphere of uncertainty, which we know will obtain for many, many, many years in the future, no matter how much more money we put into the climate models, which we do think we should put more money into the climate models. And so from end to end, as simple a structure as possible will be beneficial. It's very hard for users to really understand all of the different entities that are out there, and streamlining that would be very beneficial.
Mr. Fleming.
I would add that you seem to describe almost a matrix management approach, which I don't know if the federal government does that very well. I don't know if anyone does that very well, but I think fundamentally maintaining...
We won't get into credit default swaps and we'll be all right.
Ensuring that systems that are working now are not disrupted. So I think to varying degrees, we are able to access pretty good information, really good information from USGS and NRCS, at least in Seattle, and I think Dr. Strobel would probably echo that's the case across the Northwest and other parts of the country. So National Climate Service should not disrupt those services that are working really well. But I believe there are information gaps that a National Climate Service could step into. So it seems to me that you would want to have a service that does provide some integrated function to it, and that doesn't replicate what is working now. That's we would definitely welcome coming back to you per your invitation to the previous panel, because I think you have a organizational challenge and opportunity ahead of you in crafting this bill.
Mr. Duskin.
Well, we feel very much like, I guess you'd call us middlemen, that we need a national perspective, national modeling activities, national prediction skills that we will never have the capacity at the state level to do. And some customers want to be able to go right to that level. Other customers much prefer coming to a local level or a regional level. So it seems like there's very good reasons to have a three-tiered system where users can enter at the level that they work. Exactly how all the pieces come together, I'm not yet totally clear on either. But leveraging the skills and capabilities and activities that are already involved, you got to start there.
Mm-hmm. And the notion we've heard a great deal today also is that if you were, let's say you're an industry or you're newly appointed to run some municipality, where do you go? It takes a while just to get up to steam, and there are places where you'd like to go and they don't exist yet. We don't have the data sets, but it just takes you a while to figure out who you've got to talk to. And in your experience, is the coordination across the various agencies sufficient, or do you find that, well, I have to go to these folks for this and then these folks for this and get a little bit here, and then I piece it together with more or less degree of accuracy and certitude? How does that work? Dr. Strobel?
Well, I guess I could just say that it's getting better. The fact with the availability of the internet and the way that we can link on to other people's information and share that information, and the accessibility that folks have to access that information, not always just through our sites, but through other people's sites and linking into it, has really greatly improved the collaboration and sharing of information and the accessibility of that information. So is it perfect? No. But is it getting better? Yes. I see very positive things happening with that.
Do you feel like a climate service entity within at the federal level would help facilitate that, or create new problems?
Our department hasn't come out with a statement on this yet. I will just say that there is always benefits to more collaboration and more accessibility to information. I mean, the more we get it out to the users, the better it benefits everybody.
Mr. Fleming, and then I'll recognize my colleague.
Seattle relies on the internet to a large degree to get some of this data, particularly for the operational decisions where we're looking at weather forecasts to understand whether we need to make releases to provide flood management or to ensure that we don't scour salmon redds in the rivers that we manage. I will also add that, we have benefited immensely from having a RISA program in Seattle. The University of Washington Climate Impacts Group is a couple miles north of our offices, and we've been able to rely on them and work with them to enhance our understanding of what the implications of climate change means for our water supply. So to some degree, we definitely see the benefits of a national climate service, but we're operating from a position of having tremendous resources in our backyard.
The final thing I would just comment before I yield Mr. Inglis is that if you look historically at some of the great trends and changes in human history, the big dislocations, conflicts, it's so often climate related, and that ties to demographics. And one of the things that I struggle with is census data tells us we're looking at 139 million more people in this country in the next 40 years. Very rarely do we make informed decisions about where people can live. We don't say, gee, if you all move to the desert, you might just have a water problem. And people tend to move there and then expect somebody else to fix it. And somewhere we've got to integrate the kind of data that you folks are expert in with those kind of decisions, and we're miserable at doing that, actually. Mr. Inglis.
Thank you, Mr. Chairman. Mr. Joskin, how are state climate offices typically funded? Is it by state appropriations, or is it getting federal money, or?
It's highly variable.
Okay.
In some cases, it's on a state line item budget, but in many cases, it's within university settings. Only about 6 of us, I think, are in state government, of which South Carolina is one of those examples. So we're all fighting our own battles in various ways, but again, we're typically affiliated with universities, and universities have found us to be great assets to the research efforts and the educational efforts that go on there. So it makes some sense.
So what we're talking about here, in creating a new office, it would consolidate some of these things, or I'm not sure consolidate's the right word, create new information. What do you see as the future of climate offices, state climate offices in that?
Well, trying to find the right place for us is without asking for way more state or federal money is a real challenge. We would like to see the service that we're providing funded to the level that our states need, and whether that's through state support or whether it's through federal support, we're open either way. But we have a lot of flexibility when we're not a line of a federal agency. It gives us a lot more nimbleness on the local level. So we like to stay independent as much as we can, but would like to see additional support come to us so we have more uniformity in what we're able to do nationally.
Mm-hmm. Do climate offices, state climate offices, ever charge for their data, or how does that work? You get fees from somebody?
We charge in a way that may vary from state to state. We definitely collect revenue when we're able to help offset some of our local expenses, and we work utilizing graduate students and undergraduate students helping in our services, which is great training for them for the future as well.
Yeah. And you're the folks that set drought levels and things like that, is that right? I mean, in South Carolina, for example, would the state climate office there declare when we're at what level of drought and that sort of thing? Or?
We participate greatly in that process. State climatologists probably spend more time dealing with drought-related issues than most any of the other factors that we get to work with.
Yeah. And I guess I'm maybe asking a question I don't know because of South Carolina, but is that a call by that office, or do they work with somebody else to make the call about restrictions, for example, on water usage?
It's a function of state drought response plans, how they've been written. Usually we're advisors to the process. In only some states does the state climatologist actually make that call.
Mm-hmm. That's helpful. So do you feel that the State Climate Office's standards and expectations for climate data are met by NOAA and other federal entities involved in producing that data?
We think they're doing a pretty good job monitoring for a federal response and a regional response. For state-based responses, higher resolution information, both in time and in space, are often required, and the measurement of variables that the federal programs haven't always monitored. For example, soil moisture, evapotranspiration, things that help us with the water balance a little bit more. That's why a lot of states have gotten into data collection to fill in those gaps.
Yeah. So that's all very helpful. I think the thing that I might ask, just final question, has anybody got any additional thoughts about how to make sure that we don't create a duplicative kind of situation here in any I mean, it's been sort of the common thread from questions emanating up here. I don't know if anybody has any further observations about that.
That is one of the tough questions, and we want to neither duplicate what's out there nor create or institutionalize a dispersed structure at the climate level, as distinguished from the weather or the monitoring or data level, where obviously we've got dispersed data sources and need to collect those, and they are collected well by GS, although we pay for our GS gauges now in San Francisco because they've been discontinued by GS, and National Climate Data Center and other places where that data exists. In terms of the policy making, the decision making, the climate decadal scale information that we're starting to think about needing to plan around, as are many other stakeholder entities, the challenge is to exactly do what you posed as the challenge, which is to have as much of a centralized, but at the regional level, place for stakeholders, by the way, of varying sophistication to go to. It's worth noting that Seattle Public Utilities is probably at one end of the sophistication scale, at the high end in terms of tracking this information. And there are many others who are really struggling with where to get the climate information and how to think about it, as I think Dr. Barron alluded to as well. And we really need to meet all of those needs across the spectrum and provide as much as possible the kind of research, institution, and planning assistance that Seattle has in its backyard with the SIG program that not everybody has. That's starting to happen. We're starting to learn from examples like the RISA model, which is not duplicating what's going on anywhere else, in our view. And that is obviously one of the key questions in forming an NCS that is successful.
Yeah. Well, it might add this, Mr. Chairman. You know, it's interesting that last night we were having a dinner conversation at our house about Wikipedia and whether our girls should cite it, you know. And I think that they're more accurate. Isn't there some story about they're more accurate than Encyclopedia Britannica or something, fewer mistakes or something. And it really does show the change that information technology has brought in the way that government has to figure out a way to harness the abilities we have now, because it used to be that you had this office doing this and that one doing that and this other one doing that, and they were all funded different ways and they all had their jobs and they didn't step on each other's toes. It doesn't deliver what people need and what people expect, and it's a good expectation that they get from private vendors, is you can go to the website and you can drill down to exactly what you want. And so, you know, get down to my farm. Tell me what's the rainfall at my farm. That's really what we in government have to figure out how to deliver if we're going to remain relevant. And may put another way, deliver the kind of quality services that people expect and that they're paying for. So it really is, it's a big challenge here, is to figure out how to get this delivered in the most cost-effective, powerful way. It's very important work, and we thank you.
A fascinating line of question, as always, Mr. Inglis. As you mentioned that, I was thinking one of the questions really is, so what does it look like 10 years from now? I mean, the sort of, just as we're talking about predicting climate, let's predict the organizational structure, and what does it look like 10 years from now? And you know, is it an integrative body that creates the Google Earth that we can scan out, so I could zoom in on a computerized image of any area of our country and ultimately maybe the planet, and then time project that out on a host of variables, whether it's water supply, temperature, moisture, ground moisture, vegetation cover. I mean, I'm guessing that somewhere that may happen and would be incredibly convenient, and maybe with some depth of confidence parameters around that. But how we get there is really sort of the question, and I think you're onto something there in terms of what will that look like. Any final comments? We're about to conclude, but I can see Mr. Duskin's got something he wants to say.
But even if you're there, and I can envision that too, because we're so close to that in many ways, still converting that information to appropriate and wise decisions is a whole nother ballgame. And we see that all the time where people say, I'm smothered with data. This is fantastic. What do I do with it?
Yeah. Yeah.
And that's where a service provides that as well.
Mr. Fleming?
Just to add to that, I think that issue of what to do with the information is one where it needs to rely or reside with the local jurisdiction responsible for making those decisions. So in the case of Seattle, we certainly look for and look towards having access to that type of information. But the tacit knowledge that we have, for instance, of our water supply system is critical for making decisions, long-term decisions about what's the best course of action for that system. So I just wanted to kind of echo that, at least in our situation, having local involvement in the development of adaptation options and decision-making is essential.
Great. I thank our panelists, and we'll just conclude with the observation I made for the prior panelists. If there are thoughts or ideas or suggestions that have been stimulated by this interaction, or issues that you feel we could use some further insights into, please feel free to and ask to provide that information. As is customary, the record will stay open for 2 weeks for additional comments from members. We are grateful for the committee's the panelists' participation, and with that, this hearing stands adjourned. Thank you very much.